that range. This we will describe by taking questions here that we will clarify there. Within the range, the curve cannot be placed within that range. Within the range of the values, of those values. If suppose y, or let's assume that y is expressed in this way, and for certain value, or it is a minus x or b minus y. If I take, let's this y equal to twice a minus x into a minus x, or x minus a. Sorry, x minus a here. This is x minus a. Now in this case, the y is not correctly right. Question. Okay, now let us check that if y is expressed for y is square equal to, let me take twice x minus a, or let me take x minus a. This is x minus a into twice a minus x. Now in this case, this y square is equal to, if I put x less than a, okay, whatever a value is, if I put negative value of x, then this term will be negative. Okay, in that situation, y square is not defined because negative value will be there. So it means here for x equal to, for x less than a, if I take x less than a, this negative value, or negative a, or this is, value of x is less than a, that means this value will be negative, or y square will be negative, and is not defined. We can say that it is imaginary, value will be negative, non-real number, it will be. So y square will not be defined in this case when x is negative or less than a. Take x less than a, this negative value will be negative completely. And if x is greater than 2a, in this case, if x is greater than 2a, that means it is negative value is more than 2a, and x is greater than 2a, then also y square is negative. So this is a range here, and this range when a2, okay, 2a, let me take a, 2a greater than 2a, value of x is greater than 2a in this case, and in this case value of x is less than a. So within this period a2, 2a, or more than 2a in this case, it's more than 2a, this value is not defined. It is negative. So here the range is less than a, x is less than a, and x is greater than 2a. Okay, x is greater than 2a, x is less than a. For these values, okay, this function is not defined. So this is a range here. During this range, within this range, the function is not defined. So graph will not be there. The tracing cannot be done within this range. Okay, that will be defined. Taking questions there. Okay, so this is the third point here. The tracing of the point is not defined within certain range for which the function is not defined. The value of y square in this case will be negative, or y will be negative, which is not defined. Okay, so in this case, imaginary value will be there, non-real number will be there. So that case will not be defined. So this is how we have to find out that what is the range. Within that range, the tracing will not be possible also. Tracing cannot be done. Okay, then let's talk about other things. That what is the point of instruction also? This fourth point of it, point we are talking about. Fourth point is points of inflection. Points of inflection also we have to define. Points of inflection. If d square by upon dx square is equal to 0 and dq by upon dx cube is not equal to 0, then the points obtained from the equation of the curve and by equating d square by upon dx square or d square x upon d by square to 0. Okay, so the points will be obtained by equating this double derivative with respect to x or with respect to y to 0. From this we will obtain some points, and at that point the value of dq by or dx cube from dx cube or dq x upon dy cube is not equal to 0. If we are able to prove that they are not equal to 0, that means point of inflection will lie. Okay, or points of inflection will be there in that situation. This is also, okay, we will try to understand that sometimes this is also defined. So this is the fifth type of points we have taken. 5 points which determine symmetry. Then second point about this, origin. Okay, origin and tangents at the origin. Then double points and node, cusp or okay conjugate point we discussed about. Then points of inflection we have defined. Okay, then the sixth point or seventh point we can take that we have to solve the equation for certain points. Okay, some points of the curve which may be found will give the actual tracing, of the curve. We have to find some values of x and y so that we can trace the curve accurately or exactly. May be found will give the actual tracing of the curve. Otherwise, sometimes symmetric only, just observation, sometimes just observation does not help to trace the curve exactly. So tracing of the curve is to be done with the help of some points. Okay, what we do, we have to find out some points. Okay, if the curve is crossing the x-axis or cutting the x-axis or not cutting the x-axis. Okay, so that we have to discuss about. Seventh point, let me talk about. Find the points. Okay, on the curve which cross the axis. Okay, so axis which cross the axis means axis cutting points we have to find out by putting x equal to 0, for example, or y equal to 0. By putting x equal to 0, then the curve will cut at the y-axis. So where the curve is crossing the y-axis at x equal to 0, we can find the value of y also. Okay, putting x equal to 0, then the curve crossing the y-axis points can be obtained. Then the curve crossing or cutting the axis of y can be obtained. To solve by putting x equal to 0 in the given equation, solve for y, whatever values of y are obtained, then we can say the curve is cutting the axis of y at this point, at 0 value of x, and y coordinates are suppose a or 2a or 3a or whatever. At 0, 2a or 0a, the curve is crossing the y-axis. Similarly, by putting y equal to 0, by putting y equal to 0, we can find the points, the value of x, we can find the values of, x. Let me write here. Then asymptotes is also left over. What are the asymptotes I'll talk about? And asymptotes is also required sometimes. So y equal to 0, we can find the value of x, for y equal to 0. So these coordinates will be of the x-axis cutting points, of the points at which the curve will cross, the axis of x. Okay, if I take, suppose there is a curve here which is cutting like this, so this is the point here. Here y is 0, but let x is a. At this point the curve is cutting the x-axis. This is x-axis here. Okay, another curve, suppose this is cutting the y-axis here, like this. This point is given. Let me take this 0 and twice a. So this curve is cutting the y-axis. So here x is 0, axis of y, and on the axis of x, y is 0, a 0 suppose. This curve is cutting the y. So in this way we can find out that where the curve is crossing the two axes, if they are crossing, I mean they are cutting the x-axis or y-axis, those points of cutting or crossing can be calculated easily by putting x equal to 0 or y equal to 0 in the given equation. Whatever the values of other variable are obtained, then we can find that these are the points on the axis given where the curve is cutting or crossing the axis. Okay, so that is how we can find out the cutting points or crossing points. Now asymptotes, let me talk about what are the asymptotes. We find some parallel asymptotes to the axis of x and axis of y. Okay, so those asymptotes are also required. For the asymptotes, let me talk about. Then last point, let me take, this is 7th or 8th point, no problem. Asymptotes. What are the asymptotes here? Okay, so asymptotes are very helpful sometimes. So find the asymptotes or the tangents or the lines which are cutting the curve at 2 points, but they are not visible. I mean they are looking that these lines are cutting the curve at infinity. Okay, that is how asymptotes are infinite tangents. Find the asymptotes or the tangents which seem to meet the curve or cross the curve at infinity. But actually they cannot touch, because they look like they are intersecting. Like this is the so this is the asymptote here, which seems to cutting the curve at the axis of x at infinity, but is not clear. This may be the asymptotes, or this may be the asymptotes here. They are meeting at the infinity, meeting the axis at the infinity, the axis of x dash, y, and y dash axis. These are the tangent lines, but these tangent lines are meeting the curve at infinity at 2 points here. This is one point, this is another point. This line, which is known as asymptotes, which seems to meet the curve at axis of y at infinity along the axis of x and along the axis of y. They are meeting the curve at infinity. It looks like where for which x may be infinity, y is not infinity. In this case, if the line is going like this, and in this case y is said to be infinity, but x is not infinity. So this is how we have to take the asymptotes also. Asymptotes, find the asymptotes or the tangents which seem to meet the curve at infinity, but actually they cannot touch, or they cannot touch the curve, because they seem to meet at infinity, but actually they are not meeting. They're just shown like this. This is the curve tracing of the asymptotes here. The asymptotes are the lines which are meeting the curve at distance at infinity. There are asymptotes here. So we draw some asymptotes. Sometimes asymptotes are not meeting the curve given. So these are the asymptotes we have to define about. Point of inflection, curve, cusp, node, point of inflection or conjugate point, etc. All these things we have to know about, so that we can trace the curve easily. This is how curve tracing is there. So in case of asymptotes, when x increases, y tends to infinity. Or for values of x from 0 to plus infinity, or 0 to or minus infinity to 0. For those values, what is the value of x? For the value of y, for x from 0 to infinity, or minus infinity to 0, or 0 to minus infinity in left hand side, or to 0 to infinity positive side. This is what the value of y are obtained then. So in this case, we define that what is the asymptotes here. So asymptotes we have to find out. So asymptotes also help to trace the curve, or tracing of the curve is then easily done. So let me take now questions one by one. We have defined that what is the definitions of tracing of the curve and how they are easily done. So this is curve tracing. Some rules of curve tracing. Symmetry, we find out what the curve is symmetric to the x-axis or y-axis or both. Or they are symmetric to the line y equal to x, or they are symmetric in the two opposite quadrants. So opposite quadrants, that possibility we described. Then we describe that. That what is the points of initial. So crossing points. If the curve is crossing the axis at what point? So put x equal to 0, or y equal to 0 on axis of x. On axis of y, we have to put x equal to 0. The curve will cross the axis at what point if they are crossing? If there is no constant term, then the curve will pass to the. There is no constant term, then curve will pass to the origin. And if it is not pass to the origin, that means there is some constant term, the given equation of the curve. So this is what the curve tracing is there. Now let me take the questions one by one. First question let me talk about. That will clarify some points here. So let me take the points here. So points of intersection we have talked about, that x equal to 0 or y equal to 0. on the axis, so we have to find out those points of intersection. Okay, then we have defined almost all the points, symmetry, and regions where the curve does not exist for values of x or values of y. Okay, all those points we have defined here. Then now let me take the questions here. Okay, let me change the marker and just also. Now let me take the questions one by one. Now, first question, which is now Cartesian coordinates we are taking. Curve tracing for Cartesian coordinates is this. Okay, so this is curve tracing for Cartesian coordinates. That is there for you. Okay, so that let me talk about now. Now the first question is, let me take. Question number 1 is, it says trace the curve here x square y square equal to a square into x square plus y square. Let me take x square y square is equal to a square into x square plus y square. This is the first equation given to us. Now in this equation we see here that both x square and y square are in even terms. Okay, so they are in even terms. It means this curve is symmetric to both the axes. Okay. The curve will be symmetric to both the axes. If I further solve it, let me solve it further. Here symmetric is, let me solve here. The solution first is symmetry. Let me first find out what is symmetry. Here both the powers of x and y, both the powers of x and y are even. So the curve will be symmetric to both the axes. Will be symmetric to both the axes. Simple. To both the axes. This is one of the points here. Now let me solve this. This is first point we have found that it will be symmetric in both the axes. Now let me solve it further and find out some points where the curve is not defined. X square y square equal to a square x square plus a square y square. So let me take this x square y square to this side and then take y square common. It will be x square minus a square. This term are taken to left hand side and taking y square common. So this is x square here and minus a square equal to a square x square. That is y square is equal to a square x square upon x square minus a square. Okay. Now in this equation what we see, if I substitute here x square equal to, suppose x equal to a, for this value is not defined. For x equal to a, y square tends to infinity. Y square tends to infinity. Y square tends to infinity for x equal to 0 because this is something upon 0. Infinity. It means there is asymptote here. At x equal to a, y square tends to infinity. There is asymptote. Similarly, for y equal to a here, if I solve it further, solve for x also, let me take x here, because this is x square, okay, a square and y square is there. Similarly, for y square, for y equal to a, x square will also tends to infinity. Okay, from this equation given. So for x equal to a also, we will find that if it is a square, this will be x square, then x square minus a square equal to Okay, if I put x equal to y equal to a, this x square minus a square equal to x square only, x will cancel out, y square equal to a square, negative a square. Okay, that point will be there. This is what we have to check here. So x square minus a square or minus a square equal to x square, then x will also be negative. X square will not be defined in that situation. Okay, y tends to, in this case, y tends to infinity. Okay, so, or by defined in that situation. This is what x square tends to infinity. So it's one of the points we will define that there are some asymptotes which are at y equal to a and x equal to a. If I put x equal to minus a also, plus minus a here, x equal to minus a also. For x equal to minus a also, y tends to infinity, because minus a if I put here, then also it is not defined. And for y tends to y equal to minus a also, x square tends to infinity. That means asymptotes are there at both x equal to plus minus a and y equal to plus minus a. There are two asymptotes here. Okay. Then, so I'll just draw the figure at this point, because here x is not defined. Okay, because if I take x is less than a, okay, and if x is less than a means this value comes out to be negative. If x is less than a, let me take x is less than a here. That means this will be negative value, then y square is negative in that situation. Y square or y is then imaginary, not possible. If x is less than a in this situation, or x square is less than a square if I talk about, then y is imaginary. Y square is imaginary, or y square is negative, or y square is negative. So y is not defined in that case. Y is not defined. Y is not defined in that situation. Okay, so it means within the range x equal to plus, within the, if x is less than a, so in the may say range x equal to a or below a to a, y equal to a also, the curve is not defined. There is no curve possible, but y square is infinity, negative, y is imaginary in that situation. So curve cannot be placed in between the two values of x, values of a here. So what is the, let me draw some curve here. What kind of curve then? It will be symmetric to both the axes. So let me take what the possibility here. Now here it is, x-axis, x dash axis, this is origin O, x at x equal to a, if I draw a parallel line, this is the parallel line here. Here it is x equal to a, and here it is x equal to minus a. So these two lines which are parallel to the axis of y, but at x equal to a here, this is x equal to a at this point. And if I draw y equal to a, this is y equal to a here. Let me write here y equal to a. This is y equal to a. At y equal to a also, within these two ranges, let me take this y equal to minus a. Here it is y equal to minus a. Okay, so what is the curve here? At y equal to minus a and x equal to, this is x equal to a, this is y equal to minus a, x equal to, and here it is x equal to minus a. This is x is of y by this, but this line is x equal to minus a. Okay, so in this period, I mean in this range at x equal to a, below a, because x equal to a is below a means from a to this origin to a, in this no curve will be there, in this also there no curve, and y equal to a is this distance, y equal to minus a is this distance, so within minus a to plus a there is no curve. This curve, this I mean area, this is spacious without any tracing of the curve. So what is the curve here? Curve will be like this. These are the asymptotes which are meeting the axis along this line y equal to a. This is y equal to a, this is x equal to a. So these two lines are the asymptotes here which are meeting. Similarly here, this is the asymptotes here, no curve. Similarly in this case, if I draw one asymptote here also, okay, so this is the curve, tracing of the curve in this situation. I'm sorry, let me draw this clearly. Okay, so this is a curve tracing of this kind of figure. This is the curve tracing of this figure, because in this case, within this range x equal to a, x equal to minus a, this is x equal to minus a here, this is plus a, up to origin to this point x equal to a, and here it is x equal to minus a. So within this period there is no curve tracing is not possible, because this range x equal to a to minus a, y equal to a to minus a, this is y equal to a also. As we have seen that for these two values, these values were tends to infinity. So within those, that period when x tends to infinity, x tends to a, sorry, y square tends to infinity, or y tends to infinity. So this is the figure here, I mean curve tracing of this kind of figure. Because both powers of both x and y variables were even, so this curve is symmetric to both axes. This is symmetric to this axis, in the axis of x, axis of y is symmetric to both. In the same figure, symmetric in to x-axis, sorry, y-axis here. This is symmetric to, this is also symmetric to y-axis, the axis of x.